An intercooler is any mechanical device used to cool a fluid, including liquids or gases, between stages of a multi-stage heating process, typically a heat exchanger that removes waste heat in a gas compressor. They are used in many applications, including air compressors, air conditioners, refrigerators, and gas turbines, and are widely known in automotive use as an air-to-air or air-to-liquid cooler for forced induction internal combustion engines to improve their volumetric efficiency by increasing intake air charge density through nearly isobaric cooling. Internal combustion engines, intercoolers increase the efficiency of the induction system by reducing induction air heat created by the supercharger or turbocharger and promoting more thorough combustion. This removes the heat of compression that occurs in any gas when its pressure is raised or its unit mass per unit volume is increased. A decrease in intake air charge temperature sustains use of a more dense intake charge into the engine, as a result of forced induction. The lowering of the intake charge air temperature also eliminates the danger of pre-detonation of the fuel air charge prior to timed spark ignition. This preserves the benefits of more fuel air burn per engine cycle, increasing the output of the engine. Intercoolers also eliminate the need for using the wasteful method of lowering intake charge temperature by the injection of excess fuel into the cylinder's air induction chambers, to cool the intake air charge, prior to its flowing into the cylinders. This wasteful practice nearly eliminated the gain in engine efficiency from forced induction, but was necessitated by the greater need to prevent at all costs the engine damage that pre-detonation engine knocking causes. The inter prefix in the device name originates from historic compressor designs. In the past, aircraft engines were built with charge air coolers that were installed between multiple stages of forced induction, thus the designation of inter. Modern automobile designs are technically designated after coolers because of their placement at the end of the supercharging chain. This term is now considered archaic in modern automobile terminology, since most forced induction vehicles have single-stage superchargers or turbochargers, although aftercooler is still in common use in the piston-engined aircraft industry. In a vehicle fitted with two-stage turbocharging, it is possible to have both an intercooler and an aftercooler. The JCB Diesel Max land speed record-holding car is an example of such a system. In general, an intercooler or aftercooler is said to be a charge air cooler. Intercoolers can vary dramatically in size, shape and design, depending on the performance and space requirements of the entire supercharger system. Common spatial designs are front-mounted intercoolers, top-mounted intercoolers and hybrid-mount intercoolers. Each type can be cooled with an air-to-air system, air-to-liquid system, or a combination of both. Applications to forced induction. Turbochargers and superchargers are engineered to force more air mass into an engine's intake manifold and combustion chamber. Intercooling is a method used to compensate for heating caused by supercharging, a natural byproduct of the semi-adiabatic compression process. Increased air pressure can result in an excessively hot intake charge, significantly reducing the performance gains of supercharging due to decreased density. Increased intake charge temperature can also increase the cylinder combustion temperature, causing detonation, excessive wear, or heat damage to an engine block. Passing a compressed and heated intake charge through an intercooler reduces its temperature and pressure. If the device is properly engineered, the relative decrease in temperature is greater than the relative loss in pressure, resulting in net increase in density. This increases system performance by recovering some losses of the inefficient compression process by rejecting heat to the atmosphere. Additional cooling can be provided by externally spraying a fine mist onto the intercooler surface, or even into the intake air itself, to further reduce intake charge temperature through evaporative cooling. Intercoolers that exchange their heat directly with the atmosphere are designed to be mounted in areas of an automobile with maximum airflow. These types are mainly mounted in front-mounted systems. Cars such as the Nissan Skyline, Saab, Volvo 200 Series Turbo, Volvo 700 Series Turbo, Dodge SRT4, first-gen Mazda MX-6, Mitsubishi Lancer Evolution and Chevrolet Cobalt SS all use front-mounted intercooler, mounted near the front bumper, in line with the car's radiator. Many other turbocharged cars, particularly where the aesthetics of the car are not to be compromised by top-mount scoops, such as the Toyota Supra, Nissan 300ZX twin-turbo, Nissan Silvia, Nissan 180SX, Mitsubishi 3000 GT, Saab 900, Volkswagen, Fiat Multipla, Audi TT, and Turbo Mitsubishi Eclipse use side-mounted air-to-air intercoolers, which are mounted in the front corner of the bumper or in front of one of the wheels. Side-mounted intercoolers are generally smaller, mainly due to space constraints, and sometimes two are used to gain the performance of a larger, single intercooler. Cars such as the Subaru Impreza WRX, Mini Cooper S, Toyota Celica GT4, Nissan Pulsar GTIR, Mazda Speed 3, Mazda Speed 6, and the PSA Peugeot Citroën turbo diesels, use air-to-air top-mounted intercoolers located on top of the engine. Air is directed through the intercooler through the use of a hood scoop. In the case of the PSA cars, the air flows through the grille above the front bumper, then through underhood ducting. Top-mounted intercoolers sometimes suffer from heat diffusion due to proximity with the engine, warming them and reducing their overall efficiency. Some World Rally Championship cars use a reverse induction system design whereby air is forced through ducts in the front bumper to a horizontally mounted intercooler. Because FMIC systems require open bumper design for optimal performance, the entire system is vulnerable to debris. Some engineers choose other mount locations due to this reliability concern. FMICs can be located in front of or behind the radiator, depending on the heat dissipation needs of the engine. As well as allowing a greater mass of air to be admitted to an engine, intercoolers have a key role in controlling the internal temperatures in a turbocharged engine. When fitted with a turbo, the engine's specific power is increased, leading to higher combustion and exhaust temperatures. The exhaust gases passing through the turbine section of the turbocharger are usually around 450 degrees Celsius, but can be as high as 1000 degrees Celsius under extreme conditions. This heat passes through the turbocharger unit and contributes to the heating of the air being compressed in the compressor section of the turbo. If left uncooled, this hot air enters the engine, further increasing internal temperatures. This leads to a buildup of heat that will eventually stabilize, but this may be at temperatures in excess of the engine's design limits. Hot spots at the piston crown or exhaust valve can cause warping or cracking of these components. High air charge temperatures will also increase the possibility of pre-ignition or detonation. Detonation causes damaging pressure spikes in the engine's cylinders, which can quickly damage an engine. These effects are especially found in modified or tuned engines running at very high specific power outputs. An efficient intercooler removes heat from the air in the induction system, preventing the cyclic heat buildup via the turbocharger, allowing higher power outputs to be achieved without damage. Compression by the turbocharger causes the intake air to heat up and heat is added due to compressor inefficiencies. This is actually the greater cause of the increase in air temperature in an air charge. The extra power obtained from forced induction is due to the extra air available to burn more fuel in each cylinder. This sometimes requires a lower compression ratio be used, to allow a wider mapping of ignition timing advance before detonation occurs. On the other hand, a lower compression ratio generally lowers combustion efficiency and costs power. Some high-performance tuning companies measure the temperature before and after the intercooler to ensure the output temperature is as close to ambient as possible. Air-to-liquid intercoolers. Air-to-liquid intercoolers are heat exchangers that transfer intake charge heat to an intermediate fluid, usually water, which finally rejects heat to the air. These systems use radiators in other locations, usually due to space constraints, to reject unwanted heat, similar to an automotive radiator cooling system. Air-to-liquid intercoolers are usually heavier than their air-to-air counterparts due to additional components making up the system. The Toyota Celica GT4 had this system from 1988 to 1989, 1994 to 1999, also in the Carlos Sainz Rally Championship version from 1990 to 1993. The 1989 to 1993 Subaru Legacy with the 2.0 LDOHC flat-4 engine also used a top-installed air-to-water intercooler on the GT and RS models sold in Japan, Europe, and Australia. A big advantage of the air-to-liquid setup is the lower overall pipe and intercooler length, which offers faster response, giving peak boost faster than most front-mount intercooler setups. Some setups can use reservoirs that can have ice put into it for intake temperatures lower than ambient air, giving a big advantage. Ford had adopted the technology when they decided to use forced induction on their Mustang Cobra and Ford Lightning truck platforms. It uses a water glycol mixture intercooler inside the intake manifold, just under the supercharger, and has a long heat exchanger front-mounted, all powered by a Bosch pump made for Ford. Ford still uses this technology today with their Shelby GT500. The 2005 to 2007 Chevrolet Cobalt SS Supercharged also utilizes a similar setup. Air-to-liquid intercoolers are by far the most common form of intercooler found on marine engines, given that a limitless supply of cooling water is available and most engines are located in closed compartments where obtaining a good flow of cooling air for an air-to-air unit would be difficult. Marine intercoolers take the form of a tubular heat exchanger with the air passing through a series of tubes and cooling water circulating around the tubes within the unit's casing. The source of water for the intercooler depends on the exact cooling system fitted to the engine. Most marine engines have fresh water circulating within them which is passed through a heat exchanger cooled by seawater. In such a system, the intercooler will be attached to the seawater circuit and placed before the engine's own heat exchanger to ensure a supply of cool water. Charge air cooler. A charge air cooler is used to cool engine air after it has passed through a turbocharger, but before it enters the engine. The idea is to return the air to a lower temperature, for the optimum power for the combustion process within the engine. Charge air coolers range in size depending on the engine. The smallest are most often referred to as intercoolers and are attached to automobile engines or truck engines. The largest are reserved for use on huge marine diesel engines, and can weigh over 2 tons. Marine diesel engine charge air coolers are still manufactured in Europe, despite the very largest engines mostly being built in the Far East. Vestas Air Coil AS and GEA are the oldest makers still in business. The first marine diesel engine charge air cooler was built by Vestas Air Coil AS in 1956. There is some confusion in terminology between aftercooler, intercooler, and charge air cooler. In the past, aircraft engines would run turbochargers in stages, where the first stage compressor would feed the inlet of the second stage compressor that would further compress the air before it enters the engine. Due to the extremely high pressures that would develop, an air cooler was positioned between the first and second stage compressors. That cooler was the intercooler. Another cooler would be positioned after the second stage, which was the final compressor stage, and that was the aftercooler. An aftercooler was the cooler whose outlet fed the engine. A charge air cooler is simply an all-encompassing term, meaning that it cools the turbo's air charge before it is routed into the engine. Usually a charge air cooler means an air-to-air cooler where the heat is rejected using ambient air flowing through the heat exchanger, much like the engine's coolant radiator. While the multi-stage turbocharger systems are still in use in some tractor pull classes, selected high-performance diesels, and are also being used on newer late-model commercial diesels, the term intercooler and aftercooler are used synonymously today. The term intercooler is widely used to mean in between the turbocharger and the engine. Both terms, intercooler or aftercooler, are correct, but this is the origin of the two terms that are used interchangeably by all levels of experts. An intercooler, or charge air cooler, is an air-to-air or air-to-liquid heat exchange device used on turbocharged and supercharged internal combustion engines to improve their volumetric efficiency by increasing intake air charge density through isobaric cooling. A decrease in air intake temperature provides a denser intake charge to the engine and allows more air and fuel to be combusted per engine cycle, increasing the output of the engine. The inter prefix in the device name originates from historic compressor designs. In the past, aircraft engines were built with charge air coolers that were installed between multiple stages of supercharging, thus the designation of inter. Modern automobile designs are technically designated aftercoolers because of their placement at the end of supercharging chain. This term is now considered archaic in modern automobile terminology since most forced induction vehicles have single-stage superchargers or turbochargers. In a vehicle fitted with two-stage turbocharging, it is possible to have both an intercooler and an aftercooler. In general, an intercooler or aftercooler is said to be a charge air cooler. Text taken from Avtech Charge Air Coolers website, notes.